This video is about scientific notation. Essentially, scientific notation is a way to write really big or really small numbers in a format that is easier to manage. For example, take a look at this number. This is a 7 followed by 9 zeros, so we would read this as 7 billion, which is approximately the number of people on Earth. If you had to write this number out every time you were calculating with it, aside from being inconvenient, it would also increase the chance of making errors. So scientific notation is useful because it's going to help us get around that problem by writing the number in a more compact format. To do that, I'm going to start off by rewriting 7 billion as the product of two numbers. 7 times 1 billion equals 7 billion. That makes sense, right? But how does this help us write the number in a smaller way? I mean, if anything, now it looks bigger than it was to begin with. Well, that's where the last step comes in. What I'm going to do is now replace the 1 billion part with an equivalent power of 10, like this. 7 is still equal to 7, 10 to the 9th power is equal to 1 billion, and therefore 7 times 10 to the 9th is just another way of writing 7 billion. By the way, just in case you're wondering, the way that I knew 1 billion was equal to 10 to the 9th was just by counting the zeros. Do you see how 1 billion has 9 zeros? That's how I knew the exponent on the 10 was supposed to be a 9. In any case, this was kind of the long way to explain how scientific notation works, but I wanted to do it anyways because I think that it gives a good background to understand what's next. Now, I'm going to explain the shortcut method, and hopefully it will make sense in light of what we just went over. Take a look at this next example. You would read it as 24,530,000. Now, the shortcut method that I mentioned for converting this number into scientific notation involves counting decimal places. Watch while I demonstrate. I'm going to start off here at the end of the number where the decimal place is right now. The next step is to count the number of steps that you have to move the decimal place left in order to bring it to this position here. How many jumps are there between these two arrows? There's 7, isn't there? Another way of thinking about this is to just count how many place values are after the first number. However it is that you come up with the number 7, that's going to be the exponent on 10 when we rewrite this number in scientific notation. So we know for sure that it's going to be something times 10 to the 7th. But what is that something? Well, it turns out that I just have to look at the first few digits in the original number that are not 0, and use those as the first part of the scientific notation, like this. It'll be easiest if I just demonstrate. Notice where the decimal place is. The decimal place in this case has to go between the first and second digits, because that's where we moved it to when we were counting spaces to find the exponent, remember? Anyway, that's the final answer in scientific notation. 24,530,000 can be rewritten as 2.453 times 10 to the 7th. Let's do another example, but a little faster this time. What would this huge number be in scientific notation? Well, let's just start off by counting how many place values there are after the first digit. I counted 18 of them. Therefore, I know that the exponent on the 10 in the scientific notation form has to be an 18. I'll just write that down now. Alright, now what is the something that we need to plug in? Remember, it's just the first few digits which are not 0 in the original number. Let's plug those in, not forgetting to put that decimal place between the first and second place values. 7.73 times 10 to the 18th. That's the final answer, rewritten in scientific notation. Okay, so up until this point, the two examples that we've done so far have had to do with scientific notation as it's used to write numbers that are really big. However, as you probably noticed in the beginning of the video, I also mentioned that it's useful for writing numbers that are really small. So I just want to show one more example that has to do with that scenario. Check it out. 0.000000056. That's a really small number, but we can still use scientific notation to rewrite it. We're going to start off in a similar way by looking at the digits which form the something part of the number. It's just 5, 6, right? Because those are the only numbers that are not 0. So I'm going to put those down and place a decimal point right between them, just as we've been doing this whole time. Next, I need to find what the exponential part of the scientific notation is going to be. And to do that, I just count the number of spaces between my original decimal place, here, and the place that I moved it to, here. It looks like there are 8 spaces. You might expect then that the exponent would be 8, but it turns out that since we're rewriting a number that's very small as opposed to very large, we just have to add a negative sign, which means that the exponent is actually going to be negative 8. That's all there is to it. The final answer is 5.6 times 10 to the negative 8.